Hi everyone. So in this video, it's going to be a little bit different from what I usually do. We'll be doing some math and then some chess. So the way I might change this up as I continue, but the plan is to play like one bullet game. If I win, then I keep playing, and if I lose, I'll do a few math questions, right? Now the actual ratios of how many I'll do, what type of math questions I'll do, and that sort of stuff. Not fully sure yet. That remains to be seen. But that's the idea. So it'll essentially just be like a mix of math and chess. So it should hopefully be, I enjoy doing both of them. So it should be extra fun then. And hopefully it'll be the same for you. While the chess stuff is loading, I think my network's a little bad today. I'm gonna go and just test out. First, let me make sure I'm unmuted because that seems to be a recurring issue. Yeah, that's all good. Um, yeah, so I'll open up practice mode. And I'm not going to be picky about the years at all. I'm fine with anything. Obviously, I do care about the difficulty. Let's go until like 3, and let's not go with the really easy ones. Let's go from like 1 to 3. And regarding subjects, yeah, I'm kind of fine with anything, right? The difficulty means that it's not going to be something like Olympiad trigonometry, right? It'll be more manageable than that. This is the first one. Each side is perpendicular. All 28 of the sides are congruent. The perimeter of the polygon is 56. So they're asking us to find the area then. If the perimeter is 56, that means each side of the big triangle that you'd have, sorry, the big square. Let me screenshot this and like kind of annotate it a little over here. Give me one quick second. Uh, okay, so I'm gonna go put it here. Okay, but yeah, the point is it's going to be a square. If you like really expand everything, you're going to get something that looks like a square. And each side length there is going to be 14 because you know that the perimeter is 56, right? You can draw it out for yourself and see. Sorry, I'm just trying to like place it on the side so we can start, um, you know, you know, where I want to start. I don't want to like start in the middle of the whiteboard because I'll try to just keep one whiteboard for all of this practice so that it's a little easy for me to look back at it later. Yeah, I think this is fine. Yeah, whatever. It's something like, it's like fine now. Yeah, I've wasted enough time on this. Let's begin now. I should increase the. Yeah, okay, wait, one sec. I should be shrinking the size. Okay, sorry, I'm just trying to initialize everything. Yeah, okay. If the perimeter is 56, that tells us each side length is going to be 14, right? Because all of them are congruent. And so what we're going to end up having here is, yes, this is going to be the shape enclosing this area, right? This entire thing. And then we have a little chunk taken out like so. And then another one over here. These are all going to be congruent. So if we can find the area of one of these, we will be done. Right, now let's actually figure out the ratio of the lengths though. Well, yeah, I mean, if this is 14, this is going to be 1, 2, 3, 4, 5, 6, 7. So 14, so this is going to be 2, meaning that this will be 6 and 6. So what is the area of this? Well, this is going to be, yeah, let's just break it up into squares of 2 and 2, right? This is going to be 4, this is going to be 4 more, this is going to be 4 more. So that's 12, 16, 20, 24. So it's 24 times 4, which is 96. And the total area is 14 squared minus 96, which is just 100. So we're done. The answer should be 100, which is C. Let's see if that's correct. It is. Okay. I mean, I guess a better way of doing this would have just been to find the squares. Yeah, I mean, that definitely seems a bit faster, a bit more efficient, but that's fine. Okay, winning art design is shown. The smaller circle has radius 2 inches, with each successive circle's radius increasing by 2 inches. Which of the following is closer to the percentage of the design that's black? Okay, so it's sufficient for to do this to just kind of figure out. I mean, I think just calculate it, right? That's probably the easiest. Or maybe there's a trick that we can use, which would. No, I don't think so. So we know that the smallest one is 2, and then after that it just increases by 2, right? So let's use that information. If that's the case, what are the radii going to be? I'm going to use like a nice provocative color like red. So that's a bad word choice. But it should be something like this, right? This is kind of what we're looking for. So this has radius 2. This one has a radius of 4. Obviously, the radius isn't going to be from here, but the point is this has radius 4, 6, 8, 10, 12. So what's the total area? The total area is going to be 144 pi. What is the black area? It's going to be 12 squared minus 10 squared. We're going to have 8 squared minus 6 squared, and then 4 squared minus 2 squared. I mean, you can actually just evaluate this, but there should also be something neat going on, I think. Each of these is something minus 2, minus 2, minus 2. So this is going to be 2 times 22. It's going to be 2 times 14, 2 times 6. So you can just add these up, multiply by pi. There should be a pi at the end here as well. Sorry about that. Divided by 144 pi. Cancel, 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 72. What are we left with? We're left with 42 over 72, from which we can take out a 6, I think. So that gives us 7 over 12. And I think that's like 8. You multiply by 8.33. So that'll give you 56 plus roughly 2. So a bit above 58. So let's see what matches. Okay, apparently none of them. Let's go back and take a quick look. Where could we have made a mistake? So all this seems correct. 22 plus 14 plus 6 is 42. Yeah. Hmm. Um, I don't see anything exactly wrong with it right now. Okay, but what we're getting here is well over half, and that's obviously not right, apparently. So 2, 4, 6, 8, 10, 12. I think that I did that part correctly. Did I set up the areas right? So the 4 one should be 4 squared minus. Oh, so, wait. Yeah, I mean, that one should be 8 squared minus 6 squared. Okay, that's a radius. Are they given to be radii? Yeah, it's given radius of 2 inches, which with each successive circle's radius increasing by 2 inches. So the smallest circle is going to have a radius of 2, the next one is going to have a radius of 4. So the difference in their areas will be 4 squared minus 2 squared, which is 12 times pi. So yeah, I mean, this does give you 12 pi, even based on our calculations here. This one should then give you 64 minus 36, which is 28. Yes, and then 12 minus 10, 12 squared minus 10 squared, which is 44. So, hmm, I mean, maybe it does make sense, right? Like, I mean, if you just rearrange everything and move them all to the center, that's the that's equivalent to this. We just added up all the individual black areas, and that shouldn't change or affect anything at all. Maybe we can start by instead considering the white areas, right? What do the white areas give us? I don't think that's useful though. Okay, well, let's try it anyway. The white areas would end up giving us 2 squared plus 6 squared minus 4 squared plus 10 squared minus 8 squared. So that's not going to help. Maybe I messed up in the calculation somewhere. If you see any like obvious mistakes here, do let me know, and we can kind of work from there. Yeah, I mean, you can just kind of shift all of these up here so that they're all concentric like this. And that's not going to change anything fundamentally about the colors. So maybe I've just messed up the coloring somewhere here, but it doesn't seem that hard. Like it seems um like it should not pose so much of a challenge. Oh wait, is it like it's saying which of the following is closest to the percent? E is the closest, even though it's not accurate. So yeah, I mean, okay. So obviously something's wrong. Um, then maybe it is. Maybe it's like inverted or something. I don't know. Because I'm in black and no, that doesn't make sense. We got 58, so closest to 100 minus 58 is 42. So I'm just gonna guess A. Wait, is it maybe the color scheme is off because that's 5 over 12. So they got the exact opposite of what we have. And the way they got that is also okay. This is just weird. So 4 pi, 16 pi, 36 pi. Yeah, all that makes sense. United circles. The area of the black regions is not this. Okay, so I think we just did it wrong then. I mean, we maybe the drawing here is off or the question was different or something like that. Because what they've done is the exact opposite. They did 10 squared minus 8 squared, which is what we would have done for white instead. So maybe black and white were inverted here. I don't know because the question didn't seem hard. I don't know what the issue here is. Um, yeah, I mean, I guess I should have guessed that once I got the 7 over 12, and then obviously corresponding to that is 5 over 12. So I shouldn't have guessed 48, but I don't know. I'm not disappointed by that or anything. I think it's fine. What is the 2004th term in this sequence? So, um, I think that's like probably not a very difficult relationship here. Um, because you're basically if we write it out with variables, I think it should work out well. So let's actually try that and see. Yeah, let's just do it here. Okay. And let's check on the chess.com thing first if it's working. Yeah, okay, so we'll after this question we can start the first match. Oh, thank you, Praneel. I'm just seeing your comments now. Yeah, sorry, I didn't see them yet. Um, yeah, let's proceed with this though. In the sequence, blah blah blah. So we can just like start by writing out what the sequence is telling us. Each term after the third term is found, so starting with the fourth term is by subtracting the previous term. So a sub n plus 3 is equal to a sub n plus 1 plus a sub, well, no, should be like this. A sub n plus a sub n plus 1 minus a sub n plus 2, right? And this does this work by subtracting the previous term from the sum of the two terms that precede? Yeah, so this works. And all this tells us is that a sub n plus 3 plus a sub n plus 2 is going to be equal to this, right? That's kind of what I was thinking initially as well. And yeah, given this, we know that 2001 plus 2002 is 2003 plus something, right? And what is that something going to be? It's going to become 2000. So also, we don't need all the 2000s here because it's all addition, right? It's 2000 plus 1, 2000 plus 2 is equal to 2000 plus 3 plus 2000 plus 0. So we can just get rid of all the 2000s immediately. We'll add them back in later. And now let's think about what we have. We have 1, 2, 3, and 0. What do we get now? Now we're going to get a 5. We're just going to kind of look for a pattern here and see what we get. Now we're going to get a negative 2. Now we're going to get a 7, I think. Now we're going to get 3. Wait 1 second. Yeah, so this seems correct. 2 and 3, 0 and 5, 3 and 0, 5 and negative 2, 5 and 0 and 5, negative 2 and 7. 5 and negative 2 gives you 3, 7 and negative 4 gives you 3. Negative 2 and 7, so then this should be, what, 9? So yeah, I mean, on the one hand, you're going up by 2, etc. Right? This way. And on the other hand, you're going down by, the pattern continues like this. So it's a nice, simple pattern here. minus 2, minus 2. What we need now is the, what, 2004th term, right? Think about it. The very, very first term is positive. So, well, no, we want the 2004th term. It's got a periodicity of 2. So, all the evens are going to be part of this set. All the odds are going to be part of the 135 thing. So we start over here, and this is number. This is wait. This is the second term. This is the fourth term. This is the sixth term, and so on. So we can see the relationship now pretty clearly. 2 0, and remember we do have to add the 2000 at the end. 2 0, negative 2, negative 4, and so on. We don't actually have to solve the question from here. You can probably imagine that it's going to be a very, very negative number, right? Oh no, actually we kind of do have to do it. Sorry. How do we actually find that negative number though? So this corresponds with 2, this corresponds with 4, this corresponds with 6, this corresponds with 8. Luckily, and I mean, I don't think this is the most rigorous way of going about doing it, but we can actually just divide everything by 2. And that should not change. We can divide both this set and this, not set, this list and this list. We can just divide them both by 2. And the reason I'm doing that is because it's just going to make things easier for us, and we'll be able to see a more direct relationship here. Negative 2, negative 3, and so on. And at the bottom now we have the first term, second, third, fourth, and fifth. What are we looking for? We were looking for the 2004th term. So now we're going to be looking for the 1002nd term. Like, this is what we want. What's the relationship? It is, the sum of them is 2, right? They add up to 2, and so this is going to be negative 1000. So what is the 2004th term going to be? It's going to be twice as much of that. It's going to be negative 2000. And when you add on the other initial 2000 that we had, it'll just take us to 0. And so the answer here should be C. Yep. Next one. For what value of x does this hold? We should not be struggling too much with this. I think we can, like, so um it it's like there's a property that says, yeah, I think it's 1 2 3 4 5. So each of those things is equal to 5, so it should be 32. C. No? Okay, wait 1 second. That was a little careless of me. 5 8. Each of them is 8. So sorry. Each of them should be 2 to the 8th. Sorry, it should be, x should be 2 to the 8th, which is 256. So it should be D, right? D. Yeah, okay, sorry. Each of the terms is going to end up being equal because, like, log x base 2 is the same thing as log x squared base 4, because the 4 and the 2 you can kind of, I mean, I don't know the, I mean, I should know the formula. I have it in my head. I just don't know how to put it in words or with numbers right now. But the point is, each of these are actually the same thing. And you can test it out if you just plug in 2, for example. That will obviously show you that they're all the same thing. But even with a non-2 number, right? Because log of x base 16 is just 1/4 log x base 2. That's the relationship. And because you've got a 4 over here, which you can take out, that's going to cancel with the 1/4. Same thing here, and the 3 and 1/3 will cancel out, 2 and 1/2 will cancel out, and so on. And so each of them, there are 5 of them. So 5 times, say, y is equal to 40. So y is equal to 8. And then now you can plug that into any of these and you'll see the correct answer. Yeah, dumb mistake over there. It wasn't a hard question, it's just a stupid mistake, but let's go on. Okay, what is the average of these numbers? So there are 3 numbers a, b, and c such that all of this. I think you can just go and add up the 2 expressions, which should give you, yeah, I mean, adding them up would just give you 1001 a plus b plus c is equal to 9. So the average of them would be 9 over 3, which is b. 3, yeah. Okay. I mean, these are some pretty easy questions, but I'm not going to complain about that. I'll practice while I can. I might increase this just ever so slightly to 1.2 or 1.5. Jean has made a piece of stained glass art in the shape of 2 mountains as shown. One is 8 feet high, while the other is 12. 90-degree angle in the stage. The artwork has an area of 183 square feet. Fine. Um, what is the value of h? So I'm guessing the main thing we have to do here is kind of figure out, use the areas and see, right? And that should not be a difficult task at all. Uh, should it? No. Let me copy paste the drawing. I think I get the question. It's just 183 that I have to remember, so I'm going to not copy paste all of that text in as well. Let's go here. We'll start playing the chess games after this. I don't want to wait. Okay, one sec. Yeah, so I'm just going to draw on this. We can begin by kind of breaking this down and breaking this down. I'll also write it was 183. That's the total area. So what is the area of this section here going to be? This section is going to have an area of, I think, it should be, sorry, it's just 8 squared over 2, right? I mean, yeah, that's it. If you think of it as a full square. Yeah, I mean, the height is 8, 8 squared over 2, so 32. Similarly, this will be 72, which is 108, meaning we've got, wait, 108 is 104. Sorry, yeah, dumb mistake there. If it's 104, then this area is going to be 79. How can we find that now? I think one way that we can, something that we can use is probably finding the length over here. Well, no, wait, we can't quite do that. Okay. Um, well, we know that the area of this entire thing, first of all, what can we say about this? Must these be similar? I think this has to be a right triangle. Just because of the fact that, yeah, I mean, if that's 90-degree angle, 45, 45, 90, yeah, that has to be the case. So it is a right triangle. And when we draw this, well, we don't even need to draw it. We know that the area of the entire shape is a little bit more than 79. We want to find out what that total area is. Actually, do we have to do that? I don't think we do. Well, it's going to be um, the height times this length over here. What's the length over there though? Well, we can find that out because if this is h, this is going to be 12 minus h, right? And so this is going to be 12 minus h. If this is 8, if this is 8, this is going to be 8 minus h, and this is going to be 8 minus h, telling us that this entire thing is 20 minus 2h. Okay, the area of that of the small two triangles plus this rectangle here will give you 79. So that's all we have to do now. And to do that even better, I think we can just do, huh, yeah, I mean, we just have to do it, I think. 8 minus h squared over 2 plus 12 minus h squared whole squared over 2 plus this thing. So h times 20 minus 2h. Let's simplify that. This is all equal to 79. And now it's just a matter of solving this, right? Which should not be super difficult for us. 64 plus h squared minus, minus what? Minus 16h plus 144 plus h squared minus 24h. Is that correct? Yeah, I think it is. All divided by 2. Well, luckily for us that, yes, it's all divided by 2. Oops. Which gives us, what would this be? This would be, so this would be 210. Sorry, 208 with its 204. Yeah, 208. 208 divided by that is 104. There's an h squared, and then there's a minus 20h plus, well, okay, plus 20h. And what do we have? We have a minus 2h. So this is very, wonderful little 2h squared. Cancellations everywhere. And we're going to end up with 25 equals h squared, which means h equals 5. So B. Yep. Okay, yeah, I mean that wasn't a hard question. You just had to solve the quadratic. I'm wondering now, is there like some special trick that we could have used here? I think like just if you so uh, you could have probably plug and chugged. Maybe like sensibly you could have done something like C as your first guess, and if C, like you'll be able to then determine after plugging it in and see if it should be bigger or smaller than C, and from that then you can you can narrow down to A and B or D and E. So it's only two guesses that you have to do before you get the right answer, right? Like plugging in 2 points maximum. Doesn't matter, we got it the right way. The measures in degrees. Okay, no, we're doing some chess now, I think. Oh, question 67. Sorry, let me just check these little messages from my many fans. I got A, wait, I got B. Oh no, it's C, it's D now. Okay, so thank you, Prathian. Actually, as you can see over here, you're number two. You don't seem to be my biggest fan. I'd say that's pretty. Thank you, credits. I could say the same. If you keep sending more messages, I think you can slowly overtake Praneeth. Right? So there's a number one and a number two. So just keep working at it, and you'll get there soon. Let's play our first game now. Uh, I need to mute this 1 second. Wait, I need to figure out how to. Okay, wait, mute. Let's just get it. We've got a very nice center position here, I think. We can push, and then it's more of a close position now. We'll keep that there for now. Castle, get safe, and then we'll take with a knight, like so. Yeah, just make sure they don't fork us now. This, that's not a nice move. We can defend and just protect against the fork, obviously. So maybe, maybe just pop back here. No, yeah, okay, that works, I guess. And if they push their pawn, we just move our knight in here. And if they don't, we will start to kind of mobilize on the queen side, just a tad. If they do that, that'll be, yeah, that's very nice for us. We got an active rook now. And I think, um, yeah, let's get the bishop at this position so that it's kind of out of harm's way and we can really solidify it there. Like so. I mean, wait, do we even want to do this? Yeah, let's go with this for now. It's a pretty solid position, and we can get some more, activity with our pieces if we go for something like this. I need to be a little mindful of time. So we'll take with the rook if we do take. Yeah. Now there's a lot more pressure here, and we can kind of bring in the other rook as well to add some stress. I think he might go for a rook trade, and if he does, yeah, well, this is even better. The knight is probably dead. I don't think there's anything you can do there. Yeah. Well, no, not. He's fine, I think. Okay, bring in the second rook. Just attack the pawn. Well, yeah, I mean, you can. No, we can't take the pawn. Never mind. We might have to come back here just so we can defend. Make some way for the king. Oops. Okay, time. If he checks, I'll do that and then move the rook out. Yeah, okay, wait, we're kind of messing up now. He will get that one. Yeah, okay, I'm starting to. I played too badly with the time. Also, the pawns are probably going to end up dying quite soon. There's really nothing they can do. I just hope that, okay, if he blunders like some of his pieces, that should make things easier on me. I just don't know if that's going to happen. Yeah, okay, I'll have to sacrifice at the end. Okay, it's what's the point? Let's resign. Yeah, the problem is it's a first game, so you lose like extra points from that because I haven't played in quite some time. We'll play another one. So one loss, meaning like one. I'll change the ratio to like 5 questions per loss because that'll make it less chess and more math, which is probably for the better. Yeah, I'll try to play a little faster this time. Mm, okay, looks good to me. Yeah, the pawn might be hanging. That's the issue. So let's go with. Well, no, the knight is defending the bishop right now. So why don't we just kind of move up the queen, defend the pawn? We're good now. Uh, okay, we can kind of maybe we can get a little aggressive here. I think I want to. Oh yeah, okay, well, that was dumb. But okay, that potentially gives some. I'm fine with this. It gives it opens up the rook. Okay, so yeah, they're getting a little dangerous now, I'd say. Okay, there's really not much I can do. I don't want to let that rook in, but I can't. Okay, I can defend it like that. Yeah, that's why I was fine moving that pawn because always good to have the rook active here. We need to get rid of the bishop somehow. It's not pretty, but we'll have to settle for this. Oh, that's quite a predicament. I think we can go back here. That's like literally our only move though. Take and take back. Okay, we're up now, but not for long. Yeah, let's add some pressure. If we can trade down now, I'll be happy with that. That's good for me. So let's try to do that. I can try to just bully the queen around a little bit, or okay. So obviously they can't take now, but I can do this and then take the bishop and then try to trade the queens, and that's very agreeable for me. Okay, he won't do that, so we'll see. Just bring it all back, defend everything up, and we should be in good shape. Just don't mess up the time now. Okay, have to do this. I'm attacking the pawn again. I lose that pawn, but I can do some checks, I think. Potentially forcing. Oh yeah, I won the rook. Okay, perfect. Well, I might get mated, so I have to make sure that doesn't happen. No, I think I should be fine. Yeah, that should be fine. There's no way he can fork my rook, right? Hmm. Oh, timeout. Okay, wait. Yeah, I'm too slow on this. Let's see. That's 2 losses now. Okay, yeah, third time's the charm. So this time we'll win it, and I'll try to be better on time. I might talk a little less because I don't think that's helping me, and I'll pre-move a little more. Little gambit there. I'll try to make them push that just so. Okay, they don't want to do that. Fine. The pawn is defended now. I'm hoping they push. Actually, I don't know why I'm hoping. I'm not saying like. Yeah, let's just reroute a tad. Maybe they'll blunder the pawn there. That could be nice for us. Okay, they won't. But yeah, let's just trade down now. Yeah, they took with a better piece. I'll try to trade this as well and see. My bishops are like really bad now. Yeah, that's the issue. It's fine. We can eventually push that, and we can try to make some counter play on the queen side. The only good thing here is that my timing isn't too bad. Like I'm doing fine there. My bishop is horrible though. Did I lose something? No, not yet. Yeah. If I do this and they take with en passant, with yeah, that won't be bad for me. But I don't. Yeah, they won't though. That's the issue. Now this pawn is becoming quite a liability for me, and I'm gonna. Oh, I think I blundered the pawn over there. Yeah, I did. That's done now. Should I take that or let them? They. I mean, I should let them take it, right? So let's do this instead. Potential. Wait, where all can their knight go? Their knight can't really do much in that position. They have to defend it, or they'll take my rook first. No. Okay, I can probably try to win this pawn now because just based on the fact that I've got a bishop and they don't. I'm back down on time though, so let's fix that. Okay, yeah, I don't want to let them push. Hmm. Yeah, I'm playing pretty badly here. Okay, wait, if we take this, then we get like, wait, I can just take the knight. What am I doing? Yeah, that was a, I could still lose this. I could very well still lose this game because I don't think I'm doing so. I could have taken their knight as well. Okay, I can take the rook now, as long as I don't get mated. Well, I won't get mated. I can't get mated because the queen is pinned. Yeah, okay, yeah. Just don't blunder it now. So that should be fine. What am I doing? Okay, take. Oh, what did I do? Okay, wait, block that. Take that. Okay, yeah, I'm good now. Okay, now I need to just finally. Oh, 18 points. That's not bad. Let's uh let's not analyze that. I lost 2 games. That's like 10 more questions, but we'll try to find some. We're gonna skip this. Let's change up the topics a tad. We can do some combinatorics, intermediate combinatorics. How do you do this? Go. A large cube is painted green and then chopped up into 64 smaller congruent cubes. So that's like a 4 by 4 thing. And there's no solution to this apparently. Okay, well, let's just try the question and see. Wait, this should be like more logical, right? So it's going to be 4, so 16 on each side. How many of the smaller cubes have at least one face painted green? So let's just draw out a little scheme of this. It should be, so it's like something like this. These are always going to be separate cubes, right? So that's 4 on each of the 6 sides. So that's 24. And then these ones are repeated for 2 cubes. So it'll be 3 times 1, 2, 3, 4, 5, 6, 7, 8. So that's another 24. And then I think these ones get repeated for 3. So it's going to be 2 times this because there's 6 sides and each of these counts for 3. So it's only 2 sets. 1, 2, 3, 4, which is 8. And so that's what, 48 plus 8, which is 56. So 50, that's like almost, or actually, I think a better way of doing this would have been to just look at there'll be 8 cubes inside that don't touch anything, right? That's probably the easier way. It's 64 minus 8. Either way, the answer should be 56. Yeah, I mean, that's obviously an easier method. I just said that. But, okay, it's fine. AIME 2, question 1. Mathematical organization is producing a set of commemorative license plates. Each plate contains a sequence of 5 characters. Okay, no character, more than a month. Each possible sequence. So it's like how many sequences are there? Divide that by 10. So let's think. So you just need to choose any 5 things from this, right? The only issue is what if you choose 2 zeros, right? That's only one of the cases. So maybe we can do some case work here, right? If you do 2 zeros, then there's going to be some overcounting. So let's say there are 2 cases. There not 2 zeros, not 2 zeros, and yes, there are 2 zeros. Over here, how many ways are to choose it? Well, AIME, that's 4, and then 2007 is 3, because you're not you're one of the zeros is never going to be taken. So it's going to be 7, choose 4. right? And that's the same thing as 7 choose 3, which is 7 times 6 times 5 for 6, so that's 35. I should actually have these memorized, I think. It's probably good to do that. What if you do, wait, no, that can't be right. Oh yeah, and then you multiply by 4 factorial, sorry. Because the order does matter, right? I mean, yeah, obviously it should matter. Times 4 factorial. Well, actually, if that's the case, yeah, okay, let's just do this now. If you do have two zeros, well, first of all, that means all you have left is this because the other two zeros are already chosen. So that's 6, and you're choosing 2. So it's going to be 6 choose 2 times what? You're still going to have four numbers, but they're two zeros, so it's 4 factorial divided by 2. And what is 6 choose 2? That's 15. So it's 15 times 12, which is 180. This is going to be 35 times 24, which is, and actually, since we're dividing it by 10, so this is going to give us 18. This is going to give us 7 times 6. Oh, 6 times 7. Sorry, no, that's wrong. It's wrong. It's 7 times 12, which is 84. And that would have given you 840. Yeah, so 84 plus 18 is what? That's 102. So our answer should be 102. No, it's not. Ooh. Set of plates in which each possible sequence appears exactly once. Okay. AIME 2007. No character may appear in a sequence more times than it appears. I don't. Does this have any significance? I think that's just like a formality. I don't think that's adding any hidden meaning here. No character may appear in a sequence more times. So yeah, there's like no, you don't do AAA or anything. Um, yeah, let's see the logic. There are 8 things in total. So here we did 7 choose 4 because you're choosing. Oh wait, no, it should be 7 choose. Why is it 7 choose 4? That can't be right, right? That should be. Um, yeah, I mean it's not 7 choose 4, but and wait, it's 5 characters, so that shouldn't be 7 choose 4. This shouldn't be 6 choose 2. This should be 6 choose 3, and then the rest of the logic still applies. Sorry. And this should be 7 choose 5 with the rest of the logic still applying. And we can probably do this in a neater basis. This is 7 choose 2, which is 6 times 7 divided by 2, so that's 21 times 24. With, okay, that's one of them. And then this is going to be 6 choose 3 is 20. Yeah, 20 times what? We're multiplying it by, we're multiplying it by 12. So that's 240. This is going to be a problem though because it doesn't divide easily. Oh, wait, no, I'm dumb. It's not 4 factorial either. Why would it be 4 factorial? It'll be 5 factorial. Luckily though, that's luckily that's easy enough to fix. So let's just make this, let's do the calculation here first, which will give us what? 8, 10, 0, 4, 4, 0, 5. 504 plus 240. That's how many we have so far. And then we multiply this by 5 because there are 4 factorial, we make it 5 factorial, but we're also dividing it by 10. So we can just divide this by 2 instead. That'll give us 252 plus 120, which is nothing but 372. Yeah, okay, that's it. Dumb mistake there. This is pretty hard for a question one, I'd say. I mean, well, it's not, actually, it wasn't hard. I was just kind of dumb there. Each of the 2001 students at a high school studies Spanish or French, and some study both. The number who study Spanish is between 80 and 85%. The number is 30 and 40% at MBS ones. They're 2001 students. So, okay, wait. 2001 is divisible by 3. It is 667. It keeps coming up. I can't even make this up. 667 times 3 is 2001, I think. Yeah. Okay. And so what that means is, yeah, I mean, there's a lot of, you can have lots of different percentages here. What we need now is, so the largest number of, the greatest possible overlap will be when you have just slightly like 80 and 30% doing both, meaning the smallest number will be like around 10%, right? The largest number will then be um well, okay, let's just do it. What is 80% of 2001? We don't even need to do the division. 80% of 2001, and we need to round up. This is just going to give us 1600 and something, right? 1600.8. So that's going to become 1601, right? That's the first one. And what's the other number that they give us? 85%. Fine. What's 85%? That should just be like 100 more. So 16, wait, 1701, I think, right? Yep. So those are our first two options. These are the options for the Spanish. What about the French? It's between 30 and 40%. What is 30% of this? That's going to be 600 point 3, but that's just 601. And how about the other one? That's 40%, so that'll be 800.4 or something. So that's 801. So our minimum is going to be, actually, we don't even need to do the math here, do we? It's going to be 2001 plus, sorry, it's going to be this plus this minus 2001. And what are we're finding the difference, right? Find m minus m. So, well, okay, we're going to be subtracting this from 1701 plus 1801 minus 2001. And notice how this will cancel out with this. You just have 1701 minus 1601 plus 801 minus 601. This is 200. This is 100. And so the answer should then be 300. Right? 300. Oh, okay. Wait. If it's 85 and 40, that gives you 25%, which is roughly 500. If it is 10%, that's 200. So it's going to be like very close to this. The issue is it? Oh, for the 40%, you need to be rounding down. You can't round up. Sorry, that's very stupid of me. This should be 599, and this one should be 799. All that's really going to change is it's going to increase it by a little bit. No, wait, that doesn't seem to change anything. 1 second. Why was I adding 16? Oh, wait, I did this pretty stupidly, I think. Did I? No, wait, I think I'm fine. Okay, wait. So 1601 plus 599 now, and then 801 is 799. Is there something so wrong with the calculations here? I don't think so. Right? We're taking the lowest and the biggest, which will give you. I mean, we're really just looking at the difference between these. And the difference between the. No, wait, I'm doing something pretty stupidly here. I think um, no, wait, okay, maybe I've set it up wrong. Let's see. 2001 students at a high school study either Spanish or French. So to get the smallest number who can be studying both languages, you just want like 50. Yeah, so you take the smaller number, so 80% and 30%. 30% would give you 600. No, wait. Okay, what am I doing? It's first of all, it should not be 599. It should just be 600, right? It's going to be 600 students. This is going to be 800 students exactly. The smallest number is then this, right? How much is that? 2001, sorry, 2201 minus 2001. That's 200. This is going to give you 500. 500 minus 200. is 300. Apparently not though. So let's just like guess some numbers close to 300. 298. So let's see, where was my mistake there? Maybe I messed up in the first step. Um, well, okay, I don't see why though. So 1600 and then 80% of 1 is 0.8. So that has to go up to 1601, right? Or does it not? And either way, that shouldn't affect it. Okay, let's see their solution. I think it's just a dumb mistake somewhere. Oh, wait, no, it's not like that. These ones should go down by 1 each. This can be 601. That's not an issue. Because this is when you're going with the lower bound. This is like 80% and 30%, right? This is, so you round up. Over here, you round down because it's 85% and 40%, I think. That's a mistake. Okay, very stupid mistake there. Um, yeah, well, it's fine. We'll continue with this. At the end of a professional bowling tournament, okay, yeah, let's continue. At the end of a professional bowling tournament, the top five bowlers have a playoff. Five bowls number four. Loser receives fifth place, fifth prize, and the winner bowls three in another game. The loser of this game fourth, second. Okay, so just continue like that, and then the winner bowls on. The winner of this game gets first prize, and the loser gets second prize. In how many orders can bowlers one through five receive the prizes? Um, so essentially for the first one, so this is fifth, right? You can either have well, okay, number five can really go anywhere, right? Number five can go here, number five can go here, number five can go here, number five can go here or here. Depending on where number five goes, we can then start to, well, no, that should be a good way to think about this, right? Is it possible for number five to go ahead of number one? Yes. Is it possible for number five to go? Maybe you should work backwards. So number one can either be here or here. If number one is here, then who can we have over here? We don't know. Okay, wait. What has to happen here, I think, is let's do a few like trial rounds and see what we get. What if we have five beating four? So this will become four. Five is now over here against three. They play and five wins. Five is now here, but five loses to two and two loses to one. So okay, that's one possibility. You could also just like change the outcome of the last game and then you'd get something like this. So it doesn't, can you get any theoretical combination? You can't, right? Because the first person has to be in one of these two spots. Second person has to be in um, one of these three spots. The fourth person, sorry, the third person has to be in one of these spots. And then the fourth has to be somewhere here, which is the same as the fifth. So the fourth and the fifth can go anywhere up. The fourth and fifth can both be there. Okay, so uh, should it just be 2 times 3 times 4 times 5 then? And then maybe another 5. Well, what is this? What is this? This probably overcounts something, right? There has to be some degree of overcounting here because then we're really doing. Well, yeah, we don't need the last 5 because if you determine the positions of these players, then there's only one slot left, and that will have to go to the last person, right? They don't have five more options after that. They have to go um wherever they are. Actually, no, wait, this seems wrong because so yeah, one has two choices. One can go in either of those places. After that, one of these places is going to be out of um like number two can't take that same place. So then number two only has two options. And then so like let's say that one takes this and number two takes this. Number three has only two options. And similarly, number four will only have two options. And then after that, you actually won't have anything left at all. So it should just be 16. So it should be B. Yeah, okay. I mean, I'm guessing then this is completely generalizable. So it should just be whatever number of players you have. If that's n, it'll be 2 to the n minus 1. Because if you just added a sixth player, it would all be basically the same. Okay, this is a long problem, so I'm going to skip that. Yeah, let set A be a 90 element subset of this, and let S be the sum of the elements of A. Find the number of possible values of S. So, um, we don't need to find the actual values, we just need to find the possible values. We could also think about this as a possible number of sums of 10 numbers that you're excluding. How many unique, wait, okay, 90 elements. So yeah, you're picking 10 elements from this over here, right? You have 1, 2, 3 until 100. You're picking 10 with a unique sum. Picking 10 with a unique sum. How many possible unique sums are there? Well, let's like reduce it, right? That's actually no, wait, it shouldn't be too difficult. Mm, if you have, okay, let's start with maybe a smaller example, right? Let's just start with something like the set 1, 2, 3, 4, 5. It's something nice and easy like this. From here, you're picking three that have a distinct sum. What are the possible sums you can have? It's just so one of them is obviously the smallest one. Wait, you can have any. Wait, no, no, no. Shouldn't it just be um, any integer value from the smallest thing through the largest thing? I think it should be that, right? Intuitively, because you can by changing like one number at a time and incrementing it ever so slightly, you can always modulate it by. You can always like change the number that you have by exactly one, up or down, starting obviously with the smallest as your smallest and the biggest as your biggest. So over here it would be 6 through what? 12, which would give you seven things, right? And so over here it should be what's your largest sum of 10 numbers? Well, actually, do we even need to do all that? I don't think so. Yeah, I mean that wouldn't be very convenient for us, but so there should be, rather than actually having to evaluate 6 and 12 and then subtracting them and seeing, I think there should be a way to just do it based on the number of elements that you have. Well, no, that wouldn't really work because if you have something like 100, that would really change everything. Yeah, maybe you do have to do that. Fine. So we've got 91, 92 until 100. That would be our maximum set. The minimum one is going to be 1 through 10. The sum of this is 55. The sum of this is 90 times 10 plus 55, right? Yeah, I mean that's all it should be. So subtract, add one, 901. That's it. Okay. Next one. I don't think these AIME questions definitely look a lot harder than the ones I took when I took my AIME. So I don't know about that. Let A1 be less than A2 be less than A3. Let there be three positive integers in this interval such that A2 minus A1 is greater than 3 and A3 minus A2 is also greater than or equal to 3. How many different choices exist? Oh, I think here we can use stars and bars, right? So let's draw it out. We were, okay, wait. So the way we're going to do it is this is going to be, what are the numbers that we have? A1 and A, yeah. So this is going to be A1, this is going to be A2, and this is going to be A3. We know that because A2, so well, actually no, A2 is going to be what? Sorry. A2 is going to be this whole thing, and this whole thing is going to be A3. That kind of sets everything up now. Fine. Because A2 is greater than A1 and there are like at least three, so there have to be at least three things over here. Similarly, there have to be at least three things over here. What does this leave us with? Well, we can kind of take those three things out of the picture. They don't really matter to us now. What does matter is that you have to have 14, right? They're going to be 14 dots overall. You can now choose to place these 14 dots in any way that you choose, can't you? Yeah, you can. And so you have 14 dots to place. And I mean, I just to kind of understand, like if we put three dots here and then we put like six over here, that's nine, and then five over here. Or if we do like one, six, and seven like this, right? Something like, it sounds like my CSA teacher. Never mind. If we do something like this, we're just going to end up adding three here. We're going to add six here, and we're going to add three more over here, which will give us. Sorry, no, that doesn't really add up. No, it's not 14. It's not 14 dots. It's going to be 8 dots that we're adding. Sorry. So let's say, because we've already got 6 over here, right? So it's just going to be so it's going to be 8. So the formula should be this. But to really think about it, like let's say we're doing something to this effect. We're just going to add these many dots to each section. So 1, 2, 3, 1, 2, 1, 2, 3. And now the numbers, um, oh wait, no, there should be another option for you to put something outside, to put stuff over here. So it should actually be three bars, right? And so you could think about it as something like this. You're saying we're not going to go all the way until 14 because we don't have to go all the way until 14, right? We can just go until 12 and call it a day at that. But we still need to have three more here, and so on, right? So all we did here is now take 8 elements. We put three bars, so it's 8 plus 3 things in total, 11. Choose 3, which is 11 times 10 times 9 over 3 times 2. We can cancel out some stuff here and we get 165. Okay, so 165 should be the answer. Oh, no, it's 120. Wait, this seems like a. Uh, there are 10 different choices for A1, A2, E3. I don't think AI is very good at this. Okay, let's like. Oh, we're gonna type this in, can't we? It might be, no, like I'm sure I'm wrong, but I just want to see a proper solution because I don't know. Yeah, right here. Oh, not anymore. Yeah, it doesn't really matter. I don't think I was that off in what I did. Like, did I do something wrong? A2 minus A1 is greater than or equal to 3. A3 minus A2 is greater than or equal to 3. How many different choices of this exist? Oh, probably because you, um, yeah, so I messed up. You have to have one more over here, right? And so, oh, wait. Yeah, 10 choose 3. Okay, I'm pretty dumb. This is 11 choose 3. I forgot that it's because the minimum is 1. You still need to have at least one here, right? This includes a possibility of just taking nothing over here, right? You just place a line and then you place the dots after that, which should not be the case. So it would then become not 8 but 7 dots. So it will be 7 plus 3 choose 3, which is 10 choose 3, which is 10 times 9 times 8. Yeah, 120, right? And that's what they said as well. So that makes sense. But the idea of star, I think that's good. Just maybe tune up the difficulty, like dial it up a tad and go now. any 2 points define a line. So all we need here is, oh wait, let S be the set of points A, B in the coordinate plane where they can all be like that. Okay, how many distinct lines pass through these two members of S? So I think we should just make a rough sketch of what it would look like. So 0, 0, you can have 1 over here, you can have -1, you can have -1, and you can have 1. And it gives you a lattice that looks something like this. How many distinct lines can you have? Let's start with ones that pass through the origin. Wait, do they have to be like actual lines? Yeah, okay. Let's start with the ones that go through the origin. And let me change my color here a little. Let's go with green perhaps. So obviously you can have this one, you can have this one, you can have this one, you can have this one. Right, that's 4. And those are the only 4 that you can have that pass through the origin. What about this point? Well, so that's 4 through the origin. Let's now go back from this. Oops. Yeah, okay, so that's the first one. And now it's like symmetric, right? With any of these points, you're going to get a, well, actually, let's take these edge points, right? Wait, and there's going to be a lot of double counting. Let's just think about the slopes, right? What are all the different slopes you can have? You can have a 0 slope and you can have a +1 slope. So yeah, let's do it by that. Sorry, no, there are lots of different ones. So slopes, and we're just going to look at the absolute. No, we're not. We're just going to look at all the slopes. So what is the biggest slope you can have? The biggest slope is going to be infinity, right? And infinity just means that it's a vertical line. Okay, if you can't have infinity, what's the next best thing? Well, it's going to be 2 when you have something like this. What's the next best thing? Um, it will be 1 like this. If you can't get that, maybe you can settle for 1/2. And if you can't get that still, you'll have to go with 0. How many lines are there of slope 1 with different y-intercepts? Well, what are the different y-intercepts you can have? You can have this as your y-intercept, you can have this as your y-intercept, or you can have this as your y-intercept. There's nothing else that you can have that connects two of them. So, okay, also, let's just do the easy ones, right? Infinity, how many vertical lines? There's this one, there's this one, there's this one. That's 3. Same exact logic. How many horizontal lines? This one, this one, this one. That's another 3. How many are there of slope 1? We just saw there are 3 of them. How many are there with slope 2? 1 of these, 2 of these, and that's it. I think that's it. Oh, sorry, these are only the positive ones, right? We do also need to consider something like -1/2, -1, and then -2. These still do deserve our consideration, but they'll actually be completely symmetric to the other stuff that we did, right? So -1 is like this, boom, 3 of them. How many are there for 2? For positive, there's this one and this one, like we just said, so that's going to be 2. 1/2 is the same, it's just like rotated, so 2, 2, 2. Let's add them up. That's 8 plus 12, which is 20. So B. A frog is placed at the origin. 1 second. Yeah, Prathian still going. Let's see. A frog is placed at the origin on a number line according. Okay, this. Um, okay, I think I get the question. It's just that, uh so, um, yeah, let's think about it. So you're starting over here, right? And you're going until this point over here, which is 39. You're starting at 0. And then there's this critical point here of, no, wait, there are two critical points. There's this one over here of 13, and then there's going to be this one here of 26. And now usually you just be going in skips of 3, except you can like fast forward to 13 if you want, right? Once you're at 13, you can choose to skip forward again, or you can choose to like stay at 13, right? And so let's think about the cases in which you do go to 13 eventually, and the cases where you do not go to 13. And then after that, we'll break it up even more after that, right? And so this is, you go to 13, do not go to 13. If you go to 13, how many ways can you do that? Well, you've got 3, you've got 6, you've got 9, you've got 12. You can either go to 13 immediately, so right from here. You can go from here, you can go from here, you can go from here, you can go from here. How many is that? 1, 2, 3, 4, 5. So there are 5 ways to go to 13, right? How many ways are there to not go to 13? Well, okay, well, that's actually easier for us, right? If you don't want to go to 13 at all, first of all, where are you going to, you still have to go somewhere, right? You're going to end up at 15. Okay, let's now look at this. To go to 15, since you're not stopping at 13, you have to go up by in multiples of 3. So you're going to have to go 0, 3, 6, 9, 12, and then, sorry, this is just one jump. That's one jump. It's not down to scale. There's only one way to not go to 13, and now you'll end up at position 15. How do we proceed from here until 26? It's going to be, so let's continue this go to 13 case of ours, right? After you go to 13, so there are 5 ways to get to 13. What do you do now? You're at 13. You want to go until 26. There's a 15 here, there's an 18 here, there's a 21 here, and there's a 24 here. You can choose to take any of these. Or you can choose to take none of them. Exact same thing as before. You can have 1, 2, 3, 4, 5. There are 5 more options to get to 26 to do not go to whatever, right? Not 26. How many ways there to like not get to 26 at all? Assuming you've already been to 13. Well, after 13, you have to go to 15, 18, 21, 21, blah, blah, blah. So it's still only going to be 1, right? Okay, I mean, we've got that now. And if you don't end up going to 26, you're going to end up going to 27, right? You're going to end up going to 27. And so we've kind of fleshed out this case a little bit. Let's continue now from 26 or from 27. So from 26, you can, so what are the other multiples here? There's going to be 27, there's going to be 30, there's going to be 36, and after this, it's 39 either way, right? So if you think about it, now from 26, what do you do here? How many ways are there? Like continuing from 26, you're over here. You can either go to 27 and then 39, you can go to 27, 30, and then you can either go all the way to 39, you can go here and then here, right? So we essentially this. So that's 4. Um, yeah, so from 26, you're going to get to 39. You can choose to stop essentially at 1, 0, 1, 2, or 3 of these places. So that's it, 5 times 4. So this part is now done. What if you choose not to go instead to 26? My computer is dying, so I'll have to plug it in a second. What if you choose not to do that? You're going to be at 27. Either you do this, or you do this, which is 3 more options, right? Well, no, sorry. You can't just skip ahead now, can you? No, you can. You still can. Oh, wait, you can do that at any point, can't you? Um, Let me plug in my computer and get back to this. Give me 1 second. Because it's a little interesting. I don't want to mess up with the casework here, but it doesn't seem too difficult. It seems manageable. Sorry, you're just getting my charger. Yeah, okay. I think we're good to go. So, let's just kind of consider our casework here again, right? If you go to 13, you will end up going, then you can go to 26, or you can not go to 26, and then from 27, you can jump to 39, or you can go to 30 and then jump to 39, or you can go until 36 and then jump to 39. So to get to 36, it's 30, then 36. Yeah, okay. So I think that that's about it for what all we have to do here. So what exactly do we have now? Oh no, sorry, and okay, wait. So it's just to be very clear with what I'm doing here. It's something, it's this, right? I think that's what I'm saying. If you don't go to 26, yeah, okay. I see. So it's 5 times, and then over here it's going to be 5 times 4, and this is going to be this 1 times this 3. That's if we choose to go to the first 13. What if we choose not to go to the first 13? We're going to end up at 15. From here, there will be a few options for us. And I think now that we've already got this kind of background and how to approach the question, we can continue easily enough. Right, so you're at 15 now. You've been hopping around like this, not going to 13. You're at 15. You can now choose to not go to, you can now choose to go to 26. How many ways are there for you to just get to 26? You can go like this. You can go from 18, 21, 24. 1, 2, 3, 4. So that's 4 options, right? Um, there are 4 options to go to 26. Let's continue from here. After 26, how do you get to 39? You can go to 20, you can go straight to 39, or you can go to, so you can go from 26 to 39, 27 to 39, 30 to 39, or 36 to 39. That's 4 more. So that's going to give you 4. And what if you choose not to go to 26? This means not, I think. Yeah, so I mean, if you're not going to 26, there's only one way that you get past 26. You have to keep on jumping like this. You're going to end up at 27, after which you're presented with the exact same choice, right? Except you don't have the option of going from 26 to 39. It's just 27, 30, 36. That's 3. Very, very similar to what we had over here, right? So it's going to end up looking like this, or I mean, to be specific, it should look like this. So it's very similar calculations, I think. And this is going to end up being a lot smaller. It's going to be 16 plus what, plus 3. So 19. This is going to be 115 plus 19, which is 134. Ooh. Okay, wait, did we? A move sequence is a sequence of coordinates that corresponds to valid moves. Oh, are we? Maybe we're repeating some stuff, right? Maybe we're repeating some stuff. Actually, I don't know how that would be the case, because in each of these we're kind of examining other things, right? If you go to 13, you're gonna have a 13, which will change it from if you don't go to 13. Same thing with the 26 and the 20, not 26. If you don't, if you do choose to go to 26, there are 5 ways to get there, right? You can go from 13, 15, 18, 20, or 24. Did I label out all my multiples correctly, or did I mess up there? Let's check. So 0 to 3. Yep, there are 5 ways to get to 13 immediately. From there, if you choose to go to 26, there are going to be 1, 2, 3, 4, 5. 5 ways to get to 26. If you choose not to go to 26, there's still only one way. Let's say you're now at 26. 26. Mm, To get to 39, you can either go straight from 26 or 27, 30, 36. So that's 4. Oh, wait. Yeah, no, that makes sense. And if you're not at 26, where are you going to be? You're going to have to be at 27. In fact, you'll have to have taken one path. Are we not overcounting anything here? I don't think so. I think we're fine. So maybe I just added it wrong. What is 5 times this? It's 115. What is this? 16 plus 3, 19. 19 plus 115, 134. Yeah, not fully sure what I've done wrong here. Like the logic seems right, I think. Hmm. And it's not like you're gonna switch your order or anything, right? You have to go in a straight, like you have to keep going in one direction. How many move sequences are possible for the frog? Okay, what if you do? Is there any like special case here that I'm kind of overlooking that will end up having? Um, no, because I broke it down, right? And each of those breakdowns is different. So I'm not fully sure of what's going on here. Yeah, let's stick with this for now. Let's just see the solution, check it out. From 0 to 13, we can end at either 12 or 13. Oh, wait, I think I broke it down because after you get to 12, you don't have to go to 15 directly, right? So I think I automatically assume that, but you can also go to 13 and then 15. But I thought I accounted for that. Oh, okay, wait, I see. I see what this is. You can do, yeah, okay, so I think the main issue here was I should not have gone from here to 15. I should not have made that leap where we're going from 15 or 27. It should have instead been 24 and 12 respectively, and that would have opened up a few more options for us to have. It would have opened up 11 more options specifically, and I think I see those options right here as well. Right, one, two, three, four, five, six, and one, two, three, well, something like that. Point is, the logic was mostly right, just a small mistake there. I think that's acceptable. Oh, it's 169. Wasn't it 145? Oh no, okay, 169. Yeah, so we were pretty off there then. Two squares of a 7 by 7 checkerboard are painted yellow, the rest are painted green. Okay. If it's 7 by 7, there will be something distinct in the middle of the checkerboard. Also, so let's say look what we have here. It's a perfect 7 by 7 grid. Something like this, right? One, two, three, four, five, six, seven. Actually, I don't want to cheat. I'll just draw it properly, right? Like because I won't have these amenities with me on an actual test. One, two, they look horrible, but it's fine. One, two, three, four, five. So two more lines. Let's actually just continue a little bit here. So that's given us 2, so we need what, 5 more? 1, 2, 3, 4. Oh, ugly. 4 and 5. Okay. Where is our center square? Why I can't even locate it over here. That's not good. This one? So this is going to be our center square. And if all rotations are the same, that means that there are. So let's just like take two random ones, right? And I'll put them in. I'll circle them kind of. If you take this, you can rotate it, and you will get four different things, right? And so to this there will correspond four possibilities, because you can rotate it 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So you can rotate it four times. So everything is basically getting multiplied four times. Even if you have this center as one of your things, let's say it's this one. If you rotate it, it can also be this one, or this one. If you have this one, when you rotate it, it will end up being this one, this one, and this one, right? So, oh, I should not finish that sign. It would look very, yeah, okay. So we're not going to finish tracing it, but the point is, it's going to be, you can pick any two squares on the 14 out of the 49 squares. So 49 choose two. And I think by virtue of the fact that it's 7 by 7, I think you can just divide this by 4. Now, am I sure about this? Not fully, but this is 6. So this would be 294. Let's try it and see. You never know. It's 1996. So okay, wait. How many inequivalent color schemes are possible? What does that mean? Huh? Um, no, wait, that's what I was answering. No, wait, it's not like some. Okay. So out of 49, you're picking two of them, right? And now, any two of them are, maybe it's like a different type of rotation. Wait, did I just do the math wrong? No. Okay. Maybe we should divide by 8 instead. I don't know why that's the case, but maybe that's what's going on here. Yeah, let's just divide it once more, and that's going to give us 147. Okay, that's also wrong. How many inequivalent color schemes are possible? So, I don't know. 49 choose 2 divided by 4 is 49 times 6, which is 294. Yeah, let's see what's wrong here. Hmm. Okay. The center square is occupied in which case there are 12 cases. Okay, yeah, the first one makes sense because it's going to be. Could we have done this another way? Like, what if we did something like 48 choose 2? Yeah, I see. I think this could have worked. Divided by 4. So 48 times 47 divided by what? Divided by 8. What does this give us? This gives us 6 times 47. And that would give us minus 18. No, this would have given us the same answer. The logic itself is wrong in doing this. This is too simple. It's not actually this easy. Why is it not that easy though? right? Oh, okay, because there are cases, I guess there are cases like this as well, right? And so a case like that would actually mean, how many such cases are those are there of that? Because when I read earlier, I divided by four, but there are only two unique combinations of this. And you can have, no, wait, I don't really understand this. Let's check it out and see. Okay, so what I'm seeing here makes sense. For those symmetric about the center, there is only one other. For most pairs, there will be three other equivalent bonds. For those symmetric about the center, and there are 24. So, okay, so you break it up into two different groups. Those that are symmetric and then those that are not symmetric. And I think this, what I'm talking about here, is just a general case of them being symmetric, right? Because you can have this, but then you can also have something like this. Wait, uh, something like this, right? And so, did I do this right? This should be here. No, no. But the point is, I was a little too simple in my judgment of this. It's not always divided by four. But I mean, to our credit, the answer was close. It was only off by six, which is completely wrong. But it's not. 1 second. Can you hear me? Let's check if my audio is working. I seem to be running into some audio issues at this time. So let's see. I think Pradhan is messaging me that I'm having some. Yeah, yeah. I'm a very shy guy in that sense, Pradhan. Let's continue though. With this one. The graphs of the equations y equals k, this one and this one, are drawn in the coordinate plane. I've done this question before. I've seen this one before. These 63 lines cut part of the plane into equilateral triangles. I've done it and I graphed it out and I'm pretty sure I got it wrong the first time. So so I should do it a second time and see, right? Because they're equilateral triangles, well, like let's kind of graph it out a little. And the main line that they're giving us is just y equals k. So what we have then is, oh wait. K is a K is what's being varied. So if we take k as like 1, what we're gonna have is, let me check this. 2k, so root 3 and then negative root 3. So we would have root 3 like this passing just through. So something like this, and then also a negative analog. So these are not perpendicular, they are not, they've just got negative slopes, so not negative reciprocals. And we would have this, right? Now, when we continue this, when we move on to the next value, we're going to have something like this, and that will make one equilateral triangle, right? Not only that though, it will also make us some more equilateral triangles, like, so this, it doesn't look like it, but this is going to be an equilateral triangle. This is going to be one of them. This is going to be another one. What are the other ones that get formed? How can we like find them? And also, if we expand this, won't we get another one like this? Let's think of those questions. Okay, no, they're only giving us the 2 over root 3 ones. And I think, yeah, I mean, 2 over root 3, I think that they're referring to these triangles only. So we're fine then. We just need to see how many of these get formed, essentially. And lucky for us, here is another one that gets formed. So essentially we can see between any two lines, two values of k, we're getting two of them. Wait, that doesn't seem like it'll work though. Okay, maybe it will, maybe it won't. Like if we go up here, we're gonna have a k at this point. We're gonna have something at 2k. Why is it 2k? Like what is that? What purpose is that serving? It's gonna be like all the way off, right? Like k is going to be 10, 2k is going to be all the way up here at 20, right? Why is this? How is this going to help us in any way? That's not even forming a that's way off from what we want. So I don't know. Like actually no, I did this wrong, didn't I? We don't get lines passing through this point over here. We don't get that. That's not 2k. Well, then there should also be one over here, right? And kind of using that logic, there should also be one over here. Does this now make sense or no? Let's see. If this is the case, um, I look like a 5-year-old with this drawing. Let's make it a little neater and see. Let's just redraw it a tad, something like this perhaps. Maybe make it straight like that. Okay, yeah, then this should be fine. So I'm just going to write down a few values. This is obviously 0. This is going to be k. No, this is going to be k. This is going to be 2k, 3 halves k, and no, 3k, 4k. Okay. Negative 1k and negative 2k. So as you'd expect, that's how it's been labeled. We now have all of these horizontal lines, right? Yeah, we do. And what the other thing that we have are a few slopes, right? So one of them is going to be like this, root 3, and it's going to go all the way like this, like that. Perfect. And what this ends up doing is essentially giving us, so if this is going to be 1, this is going to be root, well, the slope is root 3, right? So it'll be tough question. Oh no, okay, so it's 30, 30, 60 degrees. So if this is 60 and these are equal, which they will have to be, it will be an equilateral triangle. What's the length of the equilateral triangle? So if this is 1, this is going to be 1 over root 3, this is going to be 2 over root 3. Perfect, that's exactly what we want. So we're going to get one of these formed. How many of these get formed in total? That's the question, right? So there's another one right here. Um, yes, 2. So now the third one is going to look, it's going to be like here. And the way it goes is kind of, so is there going to be an intersection? That's kind of what we're trying to get at, right? Won't it touch it? Like, well, okay, because it's symmetric, they'll touch right here. And so what we'll end up getting is this triangle over here, right? Yeah, we'll get another one of these. And so we've got another one here. You can continue the pattern. We'll get another one here. We'll get another one. We'll get another one. We'll get another one. Every single change like this. So as k goes up and down and everything, we're going to get one more triangle, exactly one more triangle. We can't have anything. Oh wait, can we now? Let's see this again. Ooh, the plot thickens, huh? So because the lines have the same slope, at any point that the lines intersect, the angle between them is going to have to be 60 degrees. We also know it's all symmetric. So not only do we get this triangle, but I think we also get this one over here, this one over here. And so when we do this, we're actually going to get another one here and another one here. Okay, I'm seeing it now. And like this. So another one here and another one here. Okay, we're getting a lot of triangles now. A lot more than I bargained for. And not only that, They don't end, do they? There's another one over here. Draw another line, you're going to find even more. So yeah, the lines extend forever, and so that you're going to be cutting it up a lot. And in doing that, what do you end up getting? I think you're going to have like a hmm, yeah, you're going to be cutting each of these things into a lot of different triangles, and the number of triangles that are going to be cut exactly. How can we find that? Well, um, yeah, well, it's just going to be the distance, right? So, okay, wait, give me 1 second. You're gonna like wrap my head around this. Let's see. Wait, let me check the chat once. Okay. So you can. So the line at 2K over here is going to hit it at some point. What is that point? And keeping in mind that's got a root 3 slope. Based on that, we know that we can also do it this way. This will be easier. It's got a slope of root 3, right? The height over here is going to be 2K. So won't this just be 2K over root 3? If that's the case, wait. Yeah, like, I mean, if this is the case, we're gonna have something of this sort in the end. We're gonna have lots of other ones cutting through like this as well, lots of them, and we're gonna figure out how many exactly. But the idea is that over here we have how many triangles, right? How many do we get? I think we get each of them has a radius of 2K over 3. And so what we're going to end up getting over here is this little neat little pattern. How many triangles are we going to have though? Well, on the bottom we will have 2. Sorry, it's 2K over 3. So we'll have K, and then we'll have K minus 1. Oh, wait. I think I see it now. I think I understand it now. So you're going to have, yeah, yeah. So you're going to have triangles oriented this way. You're going to have K of them over here because it's 2 over root 3, right? 2 over 3. Yes. K, you're going to have another K. And then over here, you're going to have K minus 1. The reason you're going to have K minus 1 is because this is going to be K minus, this is going to be 1 half times K minus 1 half K minus 1, 1 half K minus 1, and then there's this 1 in the middle as well. So that's going to give you K minus 1. Similarly, this is going to give you K minus 1. So you're going to have K minus 2, K minus 3, K minus 4. Right? And when you get all the way to the top, you're going to get to a point where you have like almost nothing. You know, you're going to have like just one triangle there, and that should actually be at wait, yes, that should be at so no, like okay, so at the line at K over here, you're going to have just one triangle, and it's this orientation. So you're going to have one exactly over there. It's just going to be like a small triangle, and then it continues like this. So this is like basically the scheme that we have that's going to be repeating the whole time. So something like this, right? And you can see here you've got 1 that's facing up, here you've got 2, here you've got 3. So that's following the pattern. This is 3 minus 1, 2 minus 1, 1 minus 1. Okay, we finally got the pattern. Now we just add it up, right? Um, and so how many are going to be facing up this way over here? You're going to have K, what are the bounds of K? You're going until 10. So you're starting at 0. So you're going to have 10 of them. on either direction though. No, on either direction. And so you're gonna have 2k over here. We're gonna multiply it by 2 all the way at the end because it's top and bottom. You're gonna have 2k. Um, so because k starts at 0, well, no, that's not the case. No, that's not the case. I think I messed up a little. If okay, so if the height is 2k, you need this to be 2k over root 3. This and I think is going to be 4k then, right? That's going to be 4k. Hmm. No, wait. Yeah, okay. So that's k triangles on this side. That's k triangles on this side, which is 2k. And so we're going to start with 20, right? Because we're going until 10. Does that make sense though? Let me see. So 20, then you're going to have 18, you're going to have 16, all the way until you have, is it just 2? Is it really just 2? It shouldn't even be 2, it should be 1, I think. I don't know. Yeah, I'm a little lost here. I think we should be careful. No, you're subtracting. No, you're subtracting 1 each time. You're not going to be subtracting 2 each time, right? So you're going to have 20, you're going to have 19, you're going to have 18. And if you think about it, even at this value, you're going to have something like this. You're going to have something like this, something like this. So it's still going to be broken up enough that you get these triangles, right? And so like this is one triangle, this is one triangle, this is one triangle. So it's still going to keep happening. It's just that we have to count it in a proper way. And I think the best way to do that is to, so this should have an even number. K equals 1 would have an odd number. So an odd k value will give you an odd number. You're going until what, 10? It's like the 100th time I've asked that. You're going until 10. So it's going to be 20, 19, 18, blah, 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 until just 10. Finally, right? These are for the upwards facing triangles. There should be a dot, dot, dot in here. Sorry, this is like just a little hard conceptually for me. I don't know why. But yeah, that's the case. Now, what else are we adding? We're adding upside down triangles. How many upside down triangles are we going to have? We're still actually going to have them at this stage, right? Like, so, mm, kind of now, okay, now it kind of depends on how we want to do this. Yeah, so we're going to have, at this stage, we are going to have 19, 18, 17, blah, 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 until what? Where do we stop? I would think that we stop at 11. I mean, sorry, at 10. Or wait, do we also have, yeah, I mean, I think we would stop at the stage where, 'do we stop at 10? We shouldn't have, we should, we should stop at 10, I think. The reason for that being, um, well, okay, the very last row will kind of look like this. There's nothing cutting it off over here. So you can't have, can you even have 10 then? That's the question. Well, yeah, because it'll be, so it'll be 11 minus 1. So 20 minus 1, 11 minus 1, and then you stop there. Okay, I think we're basically done now. So we add up all of these, we add up all of these, and then we multiply by 2. So what is the first one going to be? Well, how many terms? It's 10 plus 20, so it's 30 over 2 times 21 terms, I think. Sorry, 11 terms. What am I doing? 11 terms. So that's 165. What do we have over here? It'll be the same thing minus just 20, 145. Put these together and you get 310. And so when you multiply that by 2, you get 620. Yeah, I'm pretty sure this is the wrong answer. So it's not right, but it's fine. Is it 420? Oh, wait, we weren't that far off. We note that the lines partition the hexagon into disjoint unit from a series of. Okay. Oh, yeah. Well, this definitely seems like a much better approach. So can't really blame. I mean, I only have myself to blame for this. This is a pretty stupid way to set it up. Solving the above equations, we see that the hexagon in question is regular with side length. Yeah. Okay. So you found the hexagon. You found the equation. Let me record. Let me save this and like work on it later, perhaps. Yeah, that's fine. No, like let's move on right now. Many statues use a sequence of three letters followed by a sequence of three digits. And that each three-digit arrangement is equally likely. The probability that such a I saw this question on a Sohail Rathi video. Um, so okay, how many total ways are there? It's probability. So we should do the total number of ways that you can have. Uh, they're going to be 26, 26, 26, and then 10 because you can go from 0 to 9. These are the total number of things that you can have. How many palindromes do you have now? You can have 26 times 26 times 1 because you choose the first and second digits and then the third one gets decided. And then obviously with this you have 10 times 10 times 10, right? That's still there. That's not an issue. You can also have 26 times 26 times 26 times 10 times 10 times 1. But you also have to consider the fact that you could have um mm, yeah, I mean you have to consider, okay, let's actually do the division here. Divided by this, divided by this. What will these give you? This will give you 1/10. This will give you 1 over 26. There's going to be one more combination though, I think. And that's when you have two palindromes and you have to subtract this out because you're double counting it otherwise. And this is just going to be when you divide it by the same thing, this is going to give you 1 over 260. So what do we have? We have 1 over 10 plus 1 over 26 minus 1 over 260. Let's just put it all in terms of that. It's going to give you 36 minus 1 over 260, which is 35 over 260. Obviously, we need to simplify, so that'll give us 7 over 52. And yeah, that's 59. No, it's not 52. Yeah, it's 52. Sorry. So 59, hopefully. Yeah, okay, good. It's AIME 1 from like 23, 24 years ago, so it should not be hard, but that's fine. Yeah, we already saw this question. We didn't do it because it was like one of the um, long word problem things, so we just won't do that. What we should do, yeah, actually, I think it's time that I just end the stream. I don't really have much more to do now. I'll continue. Yeah, we can continue like this sort of stuff later on sometime, but right now I think this is as good a place as any to call it a day. I probably won't be doing as much streaming in the future because I'll be mainly working with my like AOps books. I'm planning to do that, meaning that it'll be mainly like more personal study. Also think I'm faster when I do it on my own, right? Because